So I have a given quantity or a given amount of soil or a core sample. I want to find out the compactness or the denseness of the material. To determine that, I need to know how much the material is weighing against the volume I can measure from it. That is density. Then the next thing is for us to determine, we have what we call the grain density, we have dry density, we have bulk density, and saturated density. I'll try as much as possible to explain these things to us. Grain density or mass of the mineral per volume of solid material. So grain density here is when I have a rock sample. Remember that every rock sample has three phases. We have, let's put it this way. A rock sample has got three phases. We have a portion of it that contains air. So we have this portion being the solid particles that are making up the rock sample. The particles you can touch and feel. Then this empty space may be filled with water or air. So if a rock sample is such that it has got three phases means three-phase rock sample means that the rock sample is porous, and as a result of the porosity, it has air voids, and part of the air voids has been filled with water. So we get three-phase. If it is two-phase, it means that you have dried the sample thoroughly to take away all water content inside it. And what other things are left? Every rock sample, a porous rock sample, has three phases sometimes, or two phases. So if I want to determine the grain density is when you have dried the sample and assuming it is possible to expel all the air, leaving only the grains that you can touch, and you are able to measure the mass of the grains against the volume of the grains, then you are talking about what? Grain density. Then dry density, mass of the mineral aggregate per volume. So per volume here means that we just pick the sample and ensure that all the water content is out. What is left is air and what? Solid, right? Air and solid. And then we decide that we want to know the dry density of the sample. So now the sample is dry. So we measure the mass of the dried sample, which means there's still some air inside, but that is what we have. So we measure the mass of the dry sample over the volume of the dry sample, and that is dry density. Then we have bulk density. Bulk density is where Mr. Sodio came to UMass with a core sample from his company. Then he tells me, Dr. Sadari, we want you to conduct some tests on these rock samples for us. And so just as he brought the sample from the field, I didn't do anything to it. There was no drying, nothing. Then I decided to measure the mass of that sample he brought, and then the volume of that sample. And then I do my calculation to get the density of that sample, that fresh sample. That is what we term as bulk density. So bulk here means that there might be water inside, there might be air inside, and there might be the solid itself. So the solid itself, the air content inside, and then the water content that might be present. All of it are untouched. We didn't determine any of them. We just measured, because it is all the three together that is giving me that rock sample. So I determine the mass and the volume, and then I calculate the density, and that is what we term as bulk density. Then saturated density is where I intentionally soak the sample for every empty space inside it to be filled with water, such that it can no longer take any fluid again. Then now I measure the volume of that sample and measure the mass of that sample, which is without air, but only water and solids. Then I decide to measure the density of that. That is what we term as saturated density. So saturation here is referring to a sample that is soaked with water fully. The International Association of Engineering Geology, they tried to group some material according to some of its physical properties, especially density and porosity. And then they said that if I have a rock sample that has got a very high porosity, porosity is a feature that can tell us whether the rock has more empty spaces and can take more fluid or not, right? And so porosity is a parameter of a rock material that is highly sought after when you are working in the oil industry or you are into mining oil. You like that parameter of the rock so much, because if your rock is porous, the probability of it having more space to absorb oil is high. But in our case as mining engineers, we don't like that, because when your rock has more empty spaces, it means it is not dense, it's not strong enough. The slightest effort on it, it will smash. And so this table is showing the various grading that we can give in terms of porosity and density. So if I have a rock that has a density of less than 1.8 grams, which means it is slightly heavier than water, that type of material is going to have a very high, we would describe the density as low, and then it is going to have what? A very high porosity value. And we can classify that as class 1. So a class 1 rock has a very high porosity but a very low density. So it means that density and porosity are more or less direct opposites of the other. So if one is high, the other becomes low, because density is referring to. Yes, so someone is asking, so if you have a very small porosity value, your density is going to be high. And that is what we want as mining engineers, because we are going to design structures where we will have heavy trucks moving on these structures. And so if your rock is that weak, it won't help. So that is it for this table. Then the next one is we trying to calculate the density of a material. So we have the mass per unit volume of a material. We can also use the mass of the solid plus the mass of the volume, the empty space there, the void, all over the total volume, and that gives us the density. Then sometimes we can use temperature as one of the functions of density. And so all you need to know is get the temperature. Density at a certain temperature will be the density of the rock at 0 degrees Celsius, and then over the coefficient of expansion of that rock material you are dealing with. And that can also give you density at a certain temperature. Yes, so if I have a very low density, porosity is going to be high, because density is talking about how compact the quantity of solids you can have in a given volume.